Alright, hello everyone. Today we're going to be talking about this here. And what does this actually mean? When we're talking about limits. So we want to estimate a limit for different values of a, where a is greater than 0. Okay. Now, to explore this using technology, I've opened Desmos and I've actually graphed the function. So I'm using x instead of h because it allows us to actually graph it and see what happens as the input approaches 0. There's a slider here as well. So we're going to have a look at what happens as a changes values. So I'm moving the slider here, and we're going to try to get it to where x is equal to 0. So you can see that x is decreasing now. X is that left point there. So it goes down, we're at 1.0.2, and then, so we can't do 0 exactly for x, but we can get very close to x, and that's kind of what this whole limit thing is about. So as h approaches 0, in this case x, same thing, we can see that that y value is about 0.69. So that's probably the closest we're going to get using this. 0.69 is our y value for when x or h approaches 0. Now we can change that to a equals 3, and we'll get a different value there. So if I put this as 3, just go 3.2, doesn't matter. And then as that x value gets to closer to 0, the y value for this one is about 1.1. Okay, so we can see that by observing these values, we can estimate the limit, and the limit depends on that value of a. Now this limit is actually equal to the natural logarithm of a. So for example, log base e, now that is also called ln, the natural logarithm of a. So this thing here is equal to these two. All right, and we can see that because if we do ln a, we will get the same. So let's go ln, what do we have over here? We had ln 3.2. And if we go back to our graph, so we can estimate it graphically, because we've got to find the point when x equals 0. X is 0 about here. And then the y value is 1 point. We'll round up to 1.16. So we can say ln 3.2 is equal to 1.16. Now we can check that with a calculator as well, and we should get around the same number there. So that's how we can estimate the value using limits and graphing it.